Morning, everyone. My name is Jonathan Roll. I'm a director at AT&T Labs, and I'm responsible for our OpenStack eComp and virtualized network deployment within the Labs organization. So I'd like to speak with you all today about what that deployment process looks like, some of the challenges that we have in the area of infrastructure deployment, and talk about how we overcome some of those challenges so that we can scale those deployments faster and more efficiently and more safely with minimal risk. So this is actually a follow-up to a lightning talk that we had yesterday, so I'm glad to see you all here. Evidently, I didn't scare anyone away too bad, or it's a new crowd today. But either way, I'm glad you're here, so let's get started. So I like to begin with the end in mind, almost no matter what it is. What's the goal and what's the objective and what's that vision? Call it vision casting, if you will. Where do we want to go? And then we'll talk about how we'll get there. So this is a recurring theme in technology in general, whether it's OpenStack or really any other technology. Just basically an engineering tenet is better, faster, or cheaper. And generally what we find is we can solve for just two of those. Hopefully we can solve for three, but most of the time we can't. But one thing we do need to do, especially if we're going to be agile and especially if we're going to support the demands and the needs of our OpenStack community internally within AT&T and then throughout the world, is we need to see the market trends before they occur, and we need to anticipate end user needs before they arise. A lot of times we have to essentially anticipate what our user community needs internally before they themselves even know why they need that. Because unless we anticipate that, often the environment readiness is late, which can then jeopardize your project. So we want to be able to anticipate those and kind of be working in lockstep with those, with all of those end user communities. So through some concepts that I'll talk about today: vision, planning, foresight, clarity of vision and goal, and stability and requirements, automation, accountability, running rules, the boundaries within which the entire ecosystem needs to operate. It can't be chaos all the time. We have to have sort of a set of principles to which we all adhere so that we can be successful. Incorporation of a DevOps culture in everything that we do, so that beginning with the end in mind means remembering how is this going to look on day two, how is it going to operate, and can it scale? And finally, incorporating feedback end to end through that entire process to ensure that we have sufficient insight as we're encountering one decision to the next. So these are some of the concepts we'll get into today. So without intervention, anyone can really scale. If you throw enough money and enough bodies at the problem, you can scale any infrastructure. So the question isn't really so much about scale, it's about scaling smart. How do you make sure you're making the right investment that's really going to meet your end users' needs to ensure optimal utilization of those resources? So we have basically on the x-axis here, we have scale over time. So how quickly, what's the rate at which we deploy our physical environments to support OpenStack and other major initiatives. And then what's the risk associated with that? The faster we go, typically the more risk we have. So basically at best, without intervention, your best hope is that you kind of got it right. And if you didn't, you're just one environment away from getting it right again. That would be actually not all bad, fairly predictable, and fairly painless in terms of course correction. But that's probably not the reality. The reality looks more like this. It's sort of a exponential kind of function where with each subsequent environment you deploy, if there's a fatal flaw in that plan, then it's not just a linear problem. It's actually becoming an exponential problem that is going to be increasingly costly to back out of and course correct from. That's probably the likeliest outcome, unfortunately, without intervention. So it becomes actually like basically a barrier, because each additional dollar you spend deploying something the wrong way or deploying the wrong thing the right way essentially leads you down a path into a black hole from which it can be very costly to back out. And so those dollars should better be spent getting the right plan on the right resources at the right time and in the right locations versus throwing good money after bad, because otherwise you wind up with an empty bank account and very little to show for it. And so you achieve basically a success barrier is what you run into. And it's difficult to propagate success when you can't really even get out of the gate due to all the money you've already spent on assets that won't work for your business. So what are some of the causes of this? Well, yesterday in our lightning talk, I talked about foundational execution problems. We talked about preparation problems, and then there's another set of problems that we'll talk about today. And I want to talk about some strategies and ideas that you can take with you back to your respective homes and work areas to essentially start to incorporate these ideas into OpenStack planning. More on the hardware and infrastructure side, but there may be ideas that you can actually adapt to software development processes too. Poor requirements is something that resonates probably with all of us. Anyone who's been in development or R&D knows without good requirements, chances are you're going to not go the right direction, more likely than not. Design churn is another big challenge that we have. If we take a prototype and we say, go build 100 of these prototypes, that's great. But if on prototype number 15, as you're stamping it out of the factory, you have a change, and then on 20, you have another change, and by the time you get to the 50th instantiation of the prototype, it's actually like you have 5 different prototypes rather than one. So design churn becomes very costly, not just in terms of dollars, but also in terms of lost time and lost resources. It's like we can never get it right. The next one's going to be better. The next one's going to be better. Well, that ends up basically being a path to foundational risk. Forecast data is something within the operator space that's really important to us. We need to know where do we need to deploy our infrastructure to host things like 5G for minimal latency, and how much infrastructure do we need? How much horsepower do we need to support that? So these are all risk factors that will become success barriers if they're not properly managed within kind of the foundational layer of the building block framework I talked about yesterday. And then there's preparation issues. So one of the ones that we encounter a lot are basically funding problems. People know that the money's needed, they're convinced why it's needed, but the process just seems to take a long time. And a lot of times you'll encounter people don't want to work without the money in the bank. And so funding problems tend to be one of our biggest ones. I highlighted in red what resonates most with us and the work that we do. For you, it may be a different problem. Supply chain and logistics is another big critical thing. Does your supply chain know all this demand that you're about to put on them is coming, and are they going to be able to fulfill it? And then logistically, can all those materials be delivered? We had a situation where we were working over Thanksgiving and Christmas, was we were launching the 3G network for the iPhone. And we were working with a contract manufacturer. This was before we got into really heavy OpenStack, more in traditional routing. And we had to, our equipment started to get held up in customs, both coming in from Mexico as well as coming in from China. And it was a surprise to all of us. So try to anticipate those things up front. Ask those questions before you attempt to scale, before you attempt to write the check and start allocating dollars. And then where will those assets live once they're on site or at your hosting provider? Are those sites ready? Will you be able to grow them in the event the thing takes off and you're really, really successful beyond your expectations? Do you have a readiness plan to achieve that and host that? Or are you going to have equipment sitting in boxes collecting dust because, Larry, who works the dock, had no idea that he needed to prepare 300,000 square feet of space for physical servers and cooling. And then staging. Do the people responsible to stage all of these, to put all those blocks together and interconnect them and put the base level of software on them, do they know? Are they staffed up? Do they actually understand how to do that? So are they ready? So these are all areas of preparation where, unless managed and unless you have the foresight to basically plan this out and see it through, you may encounter success barriers. And then there's execution problems. Installation, we talked about that a little bit from the prep stage, kind of the bridge from delivery to install staging. Installation sometimes is problematic. You can have hardware failures, cable problems, drives came in with the wrong size, they shipped the wrong components. So these are all kinds of things that can come up during the installation phase. And then validation. Was this built as designed? Or was there some sort of a fatal flaw that's going to undermine success here? So have we validated that what's actually been built is going to work and we can deploy software on it at scale? We've had a lot of lessons learned in that area. So validation is actually a really, really important step. And then turn up. After everything's been validated, after everything's been turned up and installed, or before it's been turned up, after it's been installed, after it's been validated, can it be turned up and provisioned? And then finally, can it be integrated into the rest of the network? Do the people responsible for that know what to expect? Do they know, do you have your subnet, your addressing plan? Do you have your backup procedures? And it gets into really day 2 operations at that point. And that, again, you may not even know what questions to ask. And that's why DevOps is so important, because it's the DevOps people, the people who live this, who will take the call at 3 o'clock in the morning on a Saturday night when you're fast asleep from a week's worth of coding. Those people will tell you what problems to look for in advance. And so you want to make sure you're answering their questions up front as part of this, so to avoid any surprises and any success barriers. And then there's others that essentially just spell trouble. Bad assumptions. Assumptions that you thought you had your full assumption set, you had that end-to-end view, you began with the end in mind, and still something went wrong. Bad assumptions are something that can be managed, and we'll look at that a little bit later, but that can happen, and we've all been there, and unfortunately, it's a reality of life. Cleanup efforts. In the event you take a right when you should have taken a left, how much time do you want to divert to going to clean that up versus continuing in the leftward direction and deprioritizing that so you can come back later and clean it up? It's a question you'll have to make on an individual case-by-case basis. There's not a one-size-fits-all answer, but there are techniques you can employ to help you make that decision. Whitespace problems. These are things that you basically never even anticipated in your plan. Nobody did. And then you discover them along the way. How do you deal with that? Things that maybe in the supply chain, you had no idea you needed a contract. You've never done this before. You just thought you went and purchased servers. Why do we need a contract? Well, because we're going to buy in huge volume and we're making a huge commitment on these new suppliers. So we need a contract in place. Well, how long does that take? 6 months. Whoops. And that kind of leads into the last one, which is surprises. This covers pretty much everything else. Things like, we got a new CEO. Not AT&T did not get a CEO, but happens, right? You got a new CEO. They want to take the business direction, different direction. They came from, say, IBM. Well, these are all Dells. What now? Send them back. Okay. Things like that. Things that you could never anticipate, but they happen, and they can be highly disruptive. How do you deal with those? So I describe it as smart scaling. Strategic planning, these concepts that I'm going to talk about today, really help enable smart scaling, scaling quickly with as least risk as possible, hopefully achieving 3 out of the 3, but at least faster. And they basically allow you to take that boundary of success limitations and flip it to become risk limitations, so you can manage your risk by implementing these concepts. And this allows you to transform those barriers into risk limiters and then scale your infrastructure faster, safer, and more efficiently. So let's talk about those in a little bit deeper depth. But before we do, let's transition with a quick comic. I'm sure many of you have seen this. It's a little bit old, but this is one of my favorites. For those of you who haven't seen this before, many of you have. This is the one where the customer tells you they wanted X, and what comes out the other end is Y, and it looks nothing like X. So the green arrow indicates what the customer wanted. It was a tire swing hanging from the tree. And those other 7 or 8, 9 tiles are every other conception of what it was that they actually had asked for. One's a roller coaster, one's just a rope, a 3-pedaled swing, a low swing, an easy chair in a swing. And it's really funny, but like it resonates with us because we've all been there. We've all been like, well, I thought you told us you wanted that on the left-hand side of the screen. No, I said the right-hand side of the screen. And why is it a radio button? I said a checkbox. We can do that. That's great. We can do that. Thanks for letting us know. So then you go back and you cross your fingers and you hope that when you come back, it's the lower right and it's going to be a checkbox. Might be a radio button on the top left. So this is what I call foundation risk. And again, these are due to things like poor requirements, design churn, inaccurate or missing forecast data, lack of specificity in terms of geography. Do we need a distributed plan, or do we need kind of a concentrated plan? Are we going to go occupy 300,000 square feet, or are we going to go, into 10, 30,000 square feet locations? So first off, establish joint accountability with your end users. Get them in the boat with you, join hands with them and partner with them to essentially let them know and remind them that their success and your success really have to happen together. It's not a one-sided transaction. It's a multi-sided transaction. So all of your stakeholders need to share in that accountability with you. It can't all just be on you. None of us has every single answer. Sometimes we may feel like we do, but the reality is that we don't. And so that joint accountability is really important for them to help make sure that they're giving you the information you need so that you can deliver to them what they need. And then enforce standards of quality for specificity in the requirements process, for completeness, data quality, assumption sets. That should also include priorities. In the event they give you a list of 10 requirements and you can only fulfill 8 of those, which 8 would they like? And which 2 would they prefer to defer? Due dates, design drafts, geographic needs, and any unique considerations that may exist in your particular use case. Not every case is identical. So it's up to that end user community to convey those things to you so that they can be successful. And just to level set, let me also mention that not every single instance has to go through this level of rigor. This is about scaling. This isn't about just setting up a pod or a rack in a corner. That's one thing. And you can move really fast on that. And you can buy retail, or you can buy AWS or third party or private cloud. This is for scaling. So this is after you've kind of figured out the answers to all the hard questions, and you're like 80% of the way there of what you think it needs to look like, then now it's time. Now it's like go time. Now it's time to scale up. And that's what this discussion is about. This isn't about proof of concept type of environments. So getting back to accountability and standards, baseline those requirements with your stakeholders before you set out to execute on them. And then put them under change control so that they understand the importance of getting it right. They may not the first time, and it may be like culture shock, but after you've kind of conditioned them to understand, okay, these are the 20 or 15 or hopefully fewer questions that I'm going to have to answer. And then after I answer, I need to make sure my answers are good and of high quality and valid, or else they're going to subject me to change control hell. And I don't want to go through that So I'm going to do the work up front to make sure those requirements are really good. And when I give them to them, then they'll deliver. And then set maturity milestones, what I call maturity milestones. Basically, certainty equals commitment. So the more confidence that you have in your deployment and infrastructure deployment plan, the faster you can go. The more you feel like it's stabilized, the faster you can go. And so set milestones for yourselves that allow you to kind of put in checkpoints along the way. Less mature, go slower. More mature, go faster. And that's a really easy way, setting those milestones and those decision gates, if you will, to managing your risk as you scale up. Then we get into what I call preparation risk. I can't imagine this. I cannot imagine being the architect and the crew that put this project together and came down to the last segment of the bridge over the water to find that somebody made a mistake somewhere. I don't know how you explain a project like that. That's a disaster. But there they are. And don't let that be you. So how do these things happen? Lack of funding a lot of times slow things down. You may have supply chain hiccups or bottlenecks, site readiness problems, and staging problems. From a funding and finance perspective, credibility goes a long way, and commitment to the project that you're looking to undertake. So make sure that you demonstrate a sense of commitment and credibility for your partners in the funding organization, be that CFO or whatever organization that may be, and provide credible estimates, both in the near term and in the long term, and then adjust those estimates regularly. Meet with those teams, those funding organizations. Let them know what's going on. How's the project coming along? Hey, we've got an update. Something changed. There was a price change. We needed actually more memory, and so now it's costing us more. Each server is costing us 5% more, and but our plan hasn't changed. We're calibrating a little bit differently. And then reconcile discrepancies that, when your accountant partners see discrepancies, it scares them. So reconcile those. And then prime the pump. Engage your supply chain partners, your VARs, your suppliers. Ensure that the contract and purchasing mechanisms are in place. Ensure there's enough stock and that manufacturing has the lead time they need to produce the parts, the components, the raw materials that you need. And then delivery. Make sure your transportation pipeline has the capacity to carry all this to where you need it, when you need it, at the volume you need it. And then we talked about staging and warehousing, and then the capacity of those locations and this ability to staff them and take receipt even of the boxes as they arrive. And then from a site readiness perspective, I can't give you better advice than start early. Start now. Don't wait. The lead time to condition physical environments, if you're not using, a lot of times you can buy readily available warehouse space that's already conditioned. That may be perfect for you. If you have your own space, those lead times can often take months or quarters, sometimes even a year or two, depending on zoning and permitting and all of these other factors that play into conditioning a location. And try to decouple those tasks from large-scale deployments so that they're not dependency. They're essentially like a parallel track or separated from your deployment plan so that you don't have to worry about getting sites ready. You already know they're ready. You know where your infrastructure is going. So start early on that. And then we get into something called execution risk. I feel horrible for these guys. I'm not sure if they're the crew to clean this problem up or if they're the crew to make the original mistake. But this is a school crossing in Florida, and they juxtaposed the O and the H. So somebody misspelled school in the crosswalk, and these guys have to clean it up. That's an execution risk. Somebody just, it's a Monday, maybe they had a bad day, I don't know, but that's a horribly embarrassing mistake. So they're feverishly trying to clean it up, erase it before the boss sees quick. But road paint doesn't come off that easily, I don't think. So they're having to use something pretty heavy duty there, dig into the concrete. Anyway, don't let that be you. And I'm sorry if that is you, a picture of you in a former life. So these risk factors are things like installation, validation, turn up, and then integration of your complete built system. As much as you can, simplify and standardize. I would say that complexity is the enemy in rapid scaling of OpenStack infrastructure. So basically, the simpler it is what you have to deploy, the faster you can go with that. So you could say that simplicity is proportionate to velocity. And then uniformity and standardization are close seconds and thirds. If the approach is efficient, itself is efficient, in other words, you haven't taken like a really slow process and tried to adapt it in here, you've got a relatively efficient process already in place, then those uniform and standard approaches will help you accelerate and de-risk your scaling. And they also facilitate in modularity. So the more predictable your infrastructure is, the more standard and uniform it is, the more you can take advantage of things like modularity, plug and play, pluggable components rather than physical wired cross connects. It's a lot easier to just plug something into a socket than it is to run a screwdriver and work with strands of fiber. So modularity is a huge benefit, a huge advantage, and simple architectures, standard and uniform architectures help you take advantage of things like modularity. And then DevOps automation in this execution phase. Turn up as much as possible through automation, and then through simplicity, standardization, and uniformity, successive deployments can use existing automation with minimal incremental effort. In other words, build on the automation that you already have, keep it simple, keep it standard, and then take that automation to the next level to really, really drive down that risk curve and increase your deployment velocity. Integration risk is basically lessened with successful execution of the preceding building blocks. So if you get the fundamentals and all the stages leading up to this point in your deployment, if you get those things right, then integrations should essentially snap in, we hope. And in many cases, if this is done right, it will. What are some other risks? This was the Mars lander, the Mars climate lander from late 90s, like 98, 99. And after a 286-day journey, they got to within 60 kilometers of the planet of Mars. They were going to observe and take samples of the topography for environmental reasons to look at the climate on Mars. But they ended up being about 100 kilometers closer than they had planned. And NASA, in kind of a post-op follow-up lessons learned, found that the issue was actually that they were speaking two different languages. They had to calculate thrust for the thrusters. And one team put into their software computing that based on pounds of thrust. And the other team computed it based on newtons. And no one ever did a translation. The engineers at the JPL assumed the conversion had been made, but they didn't confirm it. So they never actually validated that assumption. They just hoped it were the case and continued on. That project cost $193 million. And one of the project managers who was affiliated with that and other Mars missions was quoted as saying, better, faster, and cheaper was the mantra at the time. That's a real shame, and it burned up. So the mission ultimately was a failure for something as simple as that. So validate your assumptions. This gets back to that feedback loop, making sure that you're constantly checking in throughout the duration of your infrastructure deployment. Wherever possible, It's not always going to be easy, but wherever possible, respond rapidly to incorporate whitespace discoveries and changes in your working assumptions so that it doesn't derail your entire project. Everyone in your organization who's depending on you in your deployment, or you yourselves as you're depending on that from a development or a certification perspective, would be a lot happier waiting 2 weeks than cratering the project. So as a planning function, group, deployment function, try to respond quickly as soon as you make those new discoveries, if it can be done. And then consider other situational specific responses. Can we put it on hold? Can we continue in a different track? Can we utilize third party? There's a lot of other ways to avoid something like that destroying your project, but you do need to be smart about it. And then selectively prioritize remediation of failed deployments. This is something I talked about at the start of the talk today. So if you realize that you made a mistake or you have a change in course, you may have to prioritize the cleanup of that. You may choose to leave it at the side, shelve it, come back to it after your deployment's done or at a more suitable time. Don't make it part of the critical path if it doesn't have to be part of the critical path. Don't just assume that you found a problem, it has to be cleaned up. Is there a way for you to continue to meet the larger objectives of your business versus letting something like this derail the whole project? And then in the case of surprises, don't panic. Don't panic. Not every possibility can be managed. Not every possibility can even be predicted. You may consider an emergency pause, a timeout of a week. You may institute a protocol to say, hey, look, when these kinds of things happen, the unexpected happens, we all get together, we call a timeout, everything stops, goes on pause, and then we make sure, run through a checklist to make sure that we're not going to add to the problem, slow things down, or destroy value. And then consider implementing safeguards. So after you've discovered maybe there's a theme in the surprises you're encountering, post your resume if it's too many, cycling through too many CEOs. Safeguards can help you minimize exposure in the future. So if you do see a theme or you see something about like a signature of the surprises that you're seeing that's kind of like, okay, we've seen this too many times, let's establish operating principles so that next time it doesn't stop our project. We just invoke that plan and continue on. So wrapping up, we begin with the end in mind. So important. This is the vision. If you don't know where you want to go, how you get there is irrelevant. So begin with the end in mind and think big. Don't be afraid to think big. But don't let the pursuit of better, faster, and cheaper, while it is a laudable objective, we'd all love to do that, absolutely. But don't let that goal jeopardize and undermine your OpenStack infrastructure deployment. And then anticipate the end user needs and demands before they arise. And then scale smart through strategic planning and risk management. Use things like vision, planning, stability and clarity, running rules, DevOps culture, foresight, automation, accountability, and constant feedback in your deployment processes. And you will find that you can successfully achieve scale at a fairly rapid pace. So my name is Jonathan Roll. I appreciate your time today. I'd be happy to take any questions. We have 6 minutes. Got 6 minutes, so anyone who has any questions, be happy to take those. Okay. Go ahead. There's a mic right here, too, if you want to use the mic.
What was the worst thing you ever encountered? The worst catastrophe that you encountered scaling out?
Probably happened on the RAN side when we didn't have enough spectrum online for the 3G launch. It was a disaster. Our CTO at the time got a call over the weekend during Austin City Limits Fest. This was, I think, in July of 2009, if I'm not mistaken. And the iPhone was way bigger than we ever anticipated. Demand for it was huge, and there wasn't enough spectrum online. And so our CTO worked over the weekend with our RAN organization, actually, to turn on additional spectrum. We had the spectrum, it was there, and we even had the radios already deployed, but they were not going to be enabling that spectrum for another 5 or 6 months. They had to deploy it that weekend in response to the complaints he was getting that were escalated from people on the ground in Austin during ACL Fest. So quick recovery, and it ended up being, a success, I think, but we learned a lot of lessons in that. Okay, great. Thank you, everyone. Enjoy the conference. Thank you for being here.